So real quick, just running through scientific notation, these are the three rules. Okay, really two of them kind of go together like 1A and 1B, and then there's a rule that you can't break. So when we're talking about scientific notation, there's really two ways to look at it. If you're looking at the expanded form, and I'm telling you tomorrow, the way that I ask the question is convert it to expanded form. And what I mean by expanded form is roll that decimal out so it's the big whole number. Okay, I know on the homework it said the real number or something. Is that what it says? Real? Does it say real? Okay. The way I say it is expanded. So just kind of making sure we're on the same terms with the vernacular there. So if you see the expanded and it's greater than 1, and you have to write it in scientific notation, you need a positive exponent. So you can look at it from both perspectives. Or if you see the scientific notation and you see a negative exponent, you know that the value is going to be less than 1. So I started doing this in first period, and I think it really it made everyone kind of understand the differences here. So let's look at these two numbers. So 7.44 times 10 to the third, or 7.44 times 10 to the negative third. Visually, do those numbers look very similar based on the way that they're written? There's one key major difference, and what is that major difference? This negative sign. And it's really easy to not pay attention to that. It's really easy to kind of skip over it. But because that one little negative sign, does that drastically alter that value? Yes. So if I said I'm going to give you some money, and you got to pick which amount I'm going to give you, which color number do you want me to give you? You want the blue number. Now, if I said, hey, hang on, you've got to pay me some money, which one are you going to want to pay? You're going to want to pay the red. So if you start thinking about stuff like that in terms of money, you will kind of catch on to it a little bit quicker. Because if we write the expanded version of this, since this is a positive exponent, you know that that number is what compared to 1? Greater than 1. So how do I move the decimal to make it greater than 1? To the right, okay? So this number now becomes $7,440. Would you want that amount of money? Absolutely you would, okay? Now, the alternative to that is if you look at that red number down there, you know that because it's a negative exponent, how is that number compared to 1? Less. Well, what direction does that decimal move to be less than 1? Left, okay? So then this turns into 0.00744. None of you want that amount of money. So now, looking at it from this angle, does it make more sense how important that negative sign is? Yes, it's a drastic difference. Okay, does this help anyone visualize? I think it really does make you see it from a different perspective when you actually see the same number written the same way with only changing the exponent sign. And it does make a huge difference. So hopefully that does make a little bit more sense. So I want to work two problems from you guys' homework just to make sure we're all on the same page about everything. So if you guys will look at number 1 with me. Okay? As a matter of fact, let's not look at number 1. Let's look at number 10. So 0.000336. So I'm going to do two things with this one problem. Number 1, I'm going to do the significant figures. And number 2, I'm going to convert it to scientific notation. So let's start with significant figures first, because in your scientific notation, you must maintain significant figures. In fact, I'm going to throw you a curveball. I'm going to add a 0 to the end of that number. So your answer is going to change just a grunt. So my first question is, as this number is written now, not on your sheet of paper, how many significant figures are in that number? There are 4 of them. And if you have forgotten how we know that, is my first question is the decimal point present or absent? Present. Here's the number 1 missed thing. What side do you start on if it's present? The left, the Pacific side. I'm telling you now, that's where people mess up every single year. Okay? Now, after we decide what side we're going to start on, what's the first number we go to? The first real number, which in this case is 3, and I'm going to count it and everything to the right, which is, again, it gives me my 4. Does that make sense? Okay? Now, the second thing is we now need to convert it to scientific notation. I know it's going to be times 10 to the something. And here's where that sign comes into play. Is this a negative exponent or positive, and how do you know? Negative. How do you know? Very good. It is less than 1, and so it is negative. We don't know that yet. So we know this got to be something negative. Well, then, our third rule that we cannot break, make sure I go back the right way, is that we only need one real number left of the decimal. So when I move that decimal, when am I going to stop moving it? Okay, very good. So I'm going to go to right here. So 1, 2, 3, 4, and I'm going to stop. So the easy part is now what is my exponent value going to be? Okay, negative 4. And I know that it's going to be 3 point something. And this is where some of you kind of get in trouble. Because what we need to know is, how do I finish the rest of this? Okay, remember, you must maintain the same number of significant figures in your scientific notation as written in the original number. You told me there were 4. I've already gotten 1, so what else do I add behind it? 3, 6, 0. Just kind of talking out loud, what do you think some students would do to make this wrong? What do you think they would possibly do? A lot of people would drop that 0, and I can get it. That makes sense. I understand logically why you would say that 0 means nothing. Like, why do I have to put it? And you're right. It does kind of look like it's a waste of time and a waste of effort to put it. But if we follow the significant figure rules, we do have to include it. Now, is it something that's going to make a life or death situation? Probably not. But it is something to kind of make sure that we do try to follow the correct rules. It's the right way versus just the easy way. Okay? Any questions on that? All right, let's look at the next one. Let's go down to number 16. Insert page after. Okay, number 16 is 88,900. Okay, so let's start off with significant figures. How many would you have in that number as is? 3. Very good. Again, one more time. Decimal point present or absent? Absent. The most missed part. What side of the number do you start on? Right, or the Atlantic. So go to your first non-zero or first real number, count it and everything. So that gives you your 3. Okay. The next thing, we need scientific notation, so it's times 10 to something. Is this a positive or negative exponent, and how do you know? It's positive because it's greater than 1. Now, that looks ridiculous. I would never do that, but I'm just kind of emphasizing it at this point, so please don't write the positive number there. Now, this time, we've got to move our decimal, so one number is left of the decimal. I don't see my decimal, so where do I want to put it? And I think this is where some students kind of get confused. Okay, I want to put it right here to begin with. And then I'm going to roll it left, how many places? 1, 2, 3, and 4. So I know it's 8 point something. That's my one number. Now, I need 3 significant figures. I've already got 1, so what do I add behind it? 89. Hypothetically, what if I needed 4 significant figures? What would I do? Add a 0. Okay. The way to make this 4 significant figures, would you all agree that, like, if I put a bar right there, kind of with me, just throwing that at you? Yes, sir. Absolutely. Actually, 6, 9, and 12 are all awful problems. They're all terrible. I agree with you. Number 6, 8.27. Well, first question is it positive or negative exponent? It's positive. How many numbers are left in the decimal? 0, 8.27. That's a stupid question. I will never give you one like that. I think they were just trying to catch you, see if you knew what you were doing. 8.27 or 8.27 times 10 to the 0 makes absolutely no sense. So, again, I don't like that question. Okay? I've got to go back like this. That bar right there means that 0 is significant. So you treat it like it would be a 1 or a 1 through a 9. Does that make sense? Okay, go ahead. Yes, ma'am. Yes, ma'am. So I'm drawing a blank right now. There is a word for this thing that is before the times 10 value. Matter of fact, I didn't even finish this problem, did I? It was times 10 to the what? 4th. My bad. I totally forgot to finish that. It'll come to me one day, but there is a name for this part of the number, and that has to match. significant figure-wise? What is the name of that thing? It's really funny. It'll come to me. I'll wake up at 3 o'clock in the morning and remember it for some weird reason. Okay, any other on the top that I need to do? Go ahead. Yes, sir. Yes, sir. You would throw that 0 in right there. Yes, sir. Yes, ma'am. Yeah, I'll never give you one like that. That's a ridiculous problem. All right, I want to do two more at the bottom just to make sure we're all good there. So 4.94 times 10 to the negative 3. Now, scientific notation and counting the significant figures. Whenever you were counting them, does anyone remember what the X represented when you were counting sig figs? It represented stop. Don't count it. So nothing back here is what you deal with. You only deal with what this first part tells you. So how many significant figures are in that number? 3. Fantastic. So we need to make sure we maintain that when we go to expanded form. Now the next question is this number more than 1 or less than 1? How do you know it's less? It's a negative exponent. So if I were you, I would jot this down somewhere. So we already know that the numbers, the negative exponent means it's less than 1. And so if it's less than 1, we move the decimal which way? That's important. Okay? So if the number is less than 1, because obviously, if I start moving that decimal to the right, it's going to make it bigger. Okay? So I need to make sure that I make it smaller. Okay? So that's what we're going to do. We're going to go 1, 2, and 3. Now, what do I fill into those empty loops? Zeros. So 0.0, just 2 of them. 0.004994. And again, what else? What's missing? That leader 0. Make sure you give me that leader 0 in there. So 0.00494. Any questions on those? Pretty straightforward, right? Okay. Let's look at one more. Let's look at number 25. So 9.39 times 10 to the positive 4th. Okay. So this time, what direction, or first of all, how many significant figures do I have? Got 3. What direction do I move the decimal? Right. So if the number is greater than 1, move decimal right. Okay. We're going to move it how many places which way? Very good. So 1, 2, 3, 4. And what do I fill into those empty blanks? So 9, 3, 9, 0, 0. This is a very important question. This is the reason why I did this example. Yes or no, do you add the decimal point at the end of that number? No. And here's the reason you don't know. Let me kind of throw a side question in. Are commas appropriate? Are they fair game? In fact, I like them. That way it helps you to kind of understand them. Commas are totally different than decimal points. Okay? So you told me in the beginning there had to be 3 significant figures. As this number is currently written, how many of them are there? 3. If the decimal point is absent, as it is, we start on the right, go to our first real number, count it, and everything to the left. If you had put the decimal point at the end, is it now present? We start on the left, go to our first real number, count it, and everything. So do you agree that would be 5 versus 3? That's wrong. Okay, so the decimal point in this case does matter a lot. Everybody with me on that? Any questions? Now's the time to ask. They wouldn't. There wouldn't be a reason to. You're exactly right on that. All right, any questions? No, that was number 29, 25. You do not put the decimal. Yes, do not put that decimal there. Ooh, that was weird. Okay. All right. Anything else on the front? Again, now's the time to ask. All right. What about anything on the back? Now remember, as far as the metric system goes, let me find it. I don't know where I've done a ton of these today. Will I give you anything outside of this? No. Okay, I'm not going to give you anything outside of it. Somebody asked me this earlier. Look at number 2. It says a piece of property is found to be 499 decimeters long. Now, there are 2 D's in our ladder. Which one is deci? The little one. Remember, a decade is 10 years, right? So think about a decade as being deca, so it's a little bigger, and deci is like centi and milli. Really, really, really tiny. Okay? So everyone look at number 3, because I think this is what threw some of you off. Number 3, 12, and 13. Let me give you a huge suggestion on how to approach these, because it's a little harder to figure it out in scientific notation. What I would have done there is gotten rid of scientific notation and then move your decimal. Okay? So it says how many millimeters are there in 5? So, come on. 5.97 times 10 to the negative 6 meters. Again, what I would have done is gotten rid of scientific notation first. And so we're going to do all 3 things with this one problem. How many significant figures are in that number? 3. Now let's move it to scientific, to expanded form. What direction would I move that decimal? Left. How many places? 6. Now let's think logically here. I've got to move it 6 places to the left. So how many zeros do I need? 5. Fantastic. So 0.1, 2, 3, 4, 5, and then 597. And that's meters. Does that make sense? Okay. Now I'm trying to go from meters to what? Okay, so I'm starting at the base, and I'm ending at millis. Everyone seeing what I'm doing here? Okay, now, so if I need to move my decimal, what direction do I now need to move it to get to milli? 3 which way? 3 to the right. So 1, 2, 3. So it's now 0.00597 millimeters. Do you agree with that? Huh? But I think it's good practice because you're doing all 4 things at one time. So here's the last part. What if we wanted to convert that back to scientific notation? First question, is the exponent positive or negative? It's negative. So then what we could do is we could say that this is 5.97, 1, 2, 3, times 10 to the negative 3rd millimeters. Here's the craziest part about this entire question. Every single one of these numbers are all 100% identical. All of them are the exact same. And I know that doesn't make sense because they all look completely different, but they're all the exact same. So if I said measure it, because the units change and you're looking at scientific notation in expanded form, but all of those 4 values will all measure the exact same distance, which is crazy to think about, but it is. The reason it doesn't make sense is because you're looking at such small numbers. We've tried, and it was a miserable failure. Yeah, we tried back in the 80s with Jimmy Carter. Okay. Any other questions? Does anyone want me to do this? Any more of these? Now's the time to ask, guys. All right. Anything about density? Okay. So let's look at this real quick. Hang on. All right. So just kind of throwing this at you. If I have a cube of copper that fits in my hand, or a cube of copper that's as big as this room. Which cube, the one in my hand or the one as big as this room, has the highest density? Very good. That is a trick question. Does density change with the size of the object? No, it does not change. So keep that in mind as you go through all this. So there's 4 ways you're going to see this question tomorrow. 4 different ways. I could ask you what is the mass of an object. I could ask you what is the density of the object. I could ask you what the volume of the object is. Or I could even ask you what is the substance made out of. Now, if it says what is it made out of, what do you have to find first? You got to find the density. And on the test, there's going to be a chart of different substances with their corresponding densities. And that's how you're going to know what it's made out of. Okay? So, mathematically, if you want to know mass, what would you do? Very good. Make sure you know how you do it mathematically. It is going to be density times volume. Okay? Also, I'm going to go ahead and tell you, one of the questions may be the exact same answer all 4 times. Well, first of all, if you don't do the math right, you're going to get the wrong answer. But what I may have different each time is your unit. So make sure that you know what the unit would be whenever you're running through this stuff, because that's what's going to trip some of you up, is not knowing if your unit is correct or not. Not necessarily with water, but like if I ask you what the mass of the object is, it may be 4 grams, 4 milliliters, 4 cubic centimeters, or 4 grams per cubic centimeter. Like if you need to know the mass, what has to be the answer? 4 grams. Okay, so the unit is what I'm trying to get you to make sure that you understand. Okay, if you need to know the volume, what do you do mathematically? Mass divided by density. Also, I could ask about water displacement. If I have a graduated cylinder with 10 milliliters of water in it, and I drop a rock in it, and it goes up to 14, what's the volume of the rock? 4. Not 14, but 4. Kind of keep that in mind as well. And then obviously density is mass divided by volume. So if you have your phone or if you have a calculator, you may just kind of want to run through this real quick. See if you all can answer that question. Again, you can do it real quick. You don't have to write it down. Just if you want to punch it in your calculator on your... By the way, also, please make sure you bring a real calculator tomorrow. You will not be allowed to use a phone. Okay, and if you don't have a calculator, it's going to be a long day. So, yes, identical to this. Identical. It may be different substance. It may be different sizes and masses. The calculation, don't worry about those. I'll go ahead and tell you, remember, it's the least number of significant figures. In this case, it will be 1, but I'm never going to give you one like that. I should have written 9.0. It would make a whole lot more sense. In fact, let me do that. No, the decimal places are the math. Let me explain that real quick. 9.0. So both of those numbers have how many? So your answer would be 2. Yeah. So if it were 86.0, that would be 3. Well, 2 versus 3, what's least? 2. So your answer would have 2. And we'll go through that more in depth next week. Ow, that hurt. So my first question is, when we do density, what would be your formula? Okay, mass over volume. So it would be 86 grams divided by 9.0 cubic centimeters. Okay, so let's start with the units first. Do grams or cubic centimeters cancel each other? No. So your answer is grams per cubic centimeter. Okay, how many significant figures are in 86? There are 2. What about 9.0? 2. So your answer has 2. Now 9, 2. So what is your answer to 2 significant figures? 9.6. And again, it's 9.6 because of rounding. Well, if you need 2 significant figures, you look at the last number you need, find the last number you need, and look at the very next number to see if it rounds. Yes. Not really. The answers will be obvious what it is. The answer will be in the correct number of significant figures, but I'm not going to give you one that says 9.6 or 9 or 9.56. I'm not going to do that to you. Not yet. It'd be like 15.8 and like 0.002, like something completely obviously off the wall wrong. The way I really do this is I work the problem wrong. Like you see how you did mass divided by volume. Like I will plug in volume divided by mass. I will do density time. Yes. The thing is the reason I do it that way is because if you plug it in wrong, your answer shows up. And I do that intentionally because I want to make sure you're doing it right. And it's not something that shows up and you're like, hey, my answer's not there, and you guess and get it right. I don't want that. I want to make sure you're doing it correctly because the ACT is built the same way. They work their problems incorrectly, so your answer shows up in your calculator. And that's how it's supposed to be. Okay? All right, any questions? Any more? I mean, y'all got a few minutes left. Let me ask you this. 1D, know the difference between weight and mass. If I take you to the moon, what changes? Your weight, because what changes? Gravity, okay? Understand the purpose of units and why we use them. Okay, if I say 9.6 what? Like, if I say it's 9 meters or 9 centimeters. Now, how do you know what you're measuring? What are you measuring if it's meters and centimeters? Distance. So do you agree the unit tells you what the measurement is? It's not mass, it's not volume, it's distance. And then it tells you how large that is. It's because it's 9 meters, totally different than 9 centimeters. Very much so. So it tells you the magnitude of the amount or the size. Okay? Everything else is pretty much straightforward. Any other questions? Go ahead. Basically, when you read number 1, A through D is referring back to what that means. So if you look at where was it earlier? It says like know how to work a density problem. The other two things kind of are telling you what to do with density. It's just kind of the subset gives you the information. Okay?